I have read an article and would like to introduce BrowserAudit, a test suite and web application for automated testing of browser security features. This is a good thing to have, since it is actually difficult to implement security mechanisms according to standards and RFCs. It is a delicate thing to read these security standards and to decide if your code actually satisfies these. Hence, there's a need for an automated and efficient test suite that assesses these end product web browsers. To get there, the authors set up certain goals to how such a software should look. First of all, there should be a wide coverage, which means covering most security features, as well as that the application should be platform independent and test many different browsers on laptops, desktop, as well as phones. The application should also have high extensibility, since it is crucial that it can be updated according to the evolving standards in the future. Thirdly, the application should be easy to use, meaning accessible, with no installation or user interaction. This comes together with the next point, which is a broad audience. This because the software does not only target browser developers, but also private people who want to be more security aware and testing their browser at home. This means that the test results need to be presented in a way that it is useful for people at different levels of understanding. The last goal of the software is scalability, since the software might need to be used by lots of users simultaneously. And how did the authors achieve these goals? They started with carefully reading the specifications from HTML5, CSP, CORS, and ASTS, and from these formulate specific testing goals. With these goals, they wrote and generated more than 400 tests, focusing on asynchronicity over timeouts. First of all, these tests are more efficient. Secondly, they are easier to assure correctness, since when using timeouts, it can be a properly failed test, or just that, an actual timeout. The end result is that the authors implemented a fully automated open source web application, which tests browser security mechanisms and then presents the test results in different levels of detail for different types of users. The authors do admit that it is hard to verify that all the tests are correctly implemented, because browsers that are deployed do not typically contain intentional flaws, which means that if the test passes on all browsers, it might also mean that the test is falsely implemented. A way to circumvent this is to take an open source browser and modify its source code to fail tests on purpose, but the complexity of browsers makes this difficult. Instead, they look at known security features and issues and manually verify that these tests are accurate. During the project, they managed to find bugs in previous versions of Firefox, and by contacting Mozilla, help correct these. According to the authors, the resulting application fulfills all the set goals, meaning they do have a wide coverage, but as they state, a complete coverage is practically not feasible, and the extensibility of the server-side components is just partly finished. This is then highly connected with our next point, future work. First of all, it is crucial to keep such an application up to date, since the standards keep evolving. Secondly, as mentioned, server-side components need to be extensible so that they can then easily be updated. On top of that, one can expand the application to cover more policies, such as Flash, Java, Silverlight, and web storage. They also mentioned that one can include testing for post-message API, as well as more security features such as the X content type options header. Another mention is that it is possible to integrate the already existing House My SSL, which is another site or application, if you will, to complement their test suites. Finally, I would like to finish with my thoughts about the project. I find the application itself very useful. It also has an easy to use and understand user interface, and it does perform quite efficient within a span of 2 to 3 minutes, depending on if I use my laptop or my phone. There is sadly 2 major drawbacks that I see. One being that there is a risk that the developers are shown an exact flaw and then correct this specific flaw according to the test, but not the actual problem. The other, which I feel like a bigger issue, I have not been able to find any information that the application is being kept up to date, which means that it gets less and less useful each year. Thanks.